Welcome to video 13.8. Today we're going to be talking about piecewise functions. So what is a piecewise function? These are functions that are made up of pieces of different functions defined over specific intervals. So how do you graph a piecewise function? First, we're going to need to create a table of values for each equation separately. We only use the x values that are in the domain interval for that piece. Second, we plot the correct points. And if more are plotted than are required, you will lose points. So basically, you just have to be very careful to ensure that the points you are plotting are in the domain. If the domain is restricted on both ends, you better have endpoints on both sides of your function. Then you will use the correct endpoints for each piece, whether it's an open or a closed circle. Remember that an open circle is used when it is not included, and a closed circle is used when it is included. Let's look at exercise 1 together. This one says that we want to graph the following piecewise function. We're given a grid and we have the f of x equals x squared minus 5 over the domain from 0, including 0, up to 3. So 0 is less than or equal to x is less than 3. And then 2x minus 2 when x is greater than or equal to 3. So all the x values greater than or equal to 3. First, let's start with the top piece, the first function we're trying to graph, which is the x squared minus 5. And that piece is only graphed from x values 0 to 3. So for this table, I'm going to write x and y, and I'm going to write the x squared minus 5 above it so I know which piece I am working on. Okay, so I wrote down the x values that I care about, starting at 0 up to 3. Next, I need to get the y values that are paired with it. So go to your calculator, y equals x squared minus 5, and then we can get the y values for these specific x values. Okay, so now I have my y values. Again, I got them from the table in my calculator to be -5, -4, -1, and 4. Next, I need to decide if the endpoints here are open or closed. So if I look at the x value of 0, 0 is less than or equal to x, so that means that it is included. So next to that point, I'm going to write closed. So I remembered when I plot it to make the dot closed. Then at 3, since in my domain, 3 is just greater than x, so x is less than 3. 3 is not included, so I'm going to write open next to that. Next, I can go ahead and plot those points using the correct endpoints that I just wrote down. So I'm going to start at 0, -5, which can be a closed dot. So that's my first one at 0, -5, and then 1, -4. And these are all included since they're in the middle, so I don't have to worry about open or closed. And then 2, -1, and 3, 4, but that one needs to be an open circle. Now that I've graphed everything for that function, I need to look at the next piece. The next function is f of x equals 2x minus 2 for all the graph that is greater than or equal to 3. So first I'm going to write, just like I did here, the equation for what the table is. So I'm going to start at an x value of 3 because it says that x needs to be greater than or equal to 3, and I wrote the function, so I'm going to go to y equals, put this in y equals, and then I can see my table. I'm going to put 3 at the top, and I'm going to look at my y values. I notice that at 6 I get 10, which is the highest that my graph can go, so that's where I'm going to write my table, from 3 to 6. Okay, and again, this was just right from my table, 3, 4, 4, 6, 5, 8, 6, 10 in my table. Now I'm going to go over to my graph. Since this is closed, and since this isn't an endpoint, it's everything greater than, I don't have to worry about what to use for this point. I'm going to go right past it and show an arrow because all the x values greater than are included in this function. So the first point is at 3, 4, which overlaps with our other function, but the other function was an open circle. So this still passes the vertical line test. X technically gets really close to 4 here, but it's open, so it's not included. But then since this point is closed, and it's a point on this function as well, I use a closed dot to fill in the original open circle. And then I'll plot the other points. And I didn't connect my first function, which I probably should have done right away. I just connected those now, and now I'm going to use a straight edge to connect the rest of my function. And then I just have my arrow. And I don't have to put a label or anything on this because this is actually just the graph of one function. Okay, so we'll look some more at piecewise functions in class tomorrow. Have a good night.